All right, everyone, let's go to 2.5, page 10. 2.5, page 10. So what we're going to do is we are going to actually model some data using linear graphs. So we are going to first recall graphing these data points. So these are scatter plots. This table shows you the average monthly temperature and electricity cost for a Texas home in 2008. And the table below shows the rounded to the nearest whole number. Make a scatter plot. How would you describe the correlation? So go ahead and plot these temperature versus electricity bill first. So really quickly, don't try to spend a lot of time making it perfect. We just want general idea of where the temperature versus electricity bill is. Okay, does everyone know what to do? So for example, the first one, 61, 150. So you go to around 61 on the temperature, which is the x coordinate, and then electricity bill is the y coordinate. So 61, 150 is probably around here. So it doesn't have to be perfect. It doesn't have to be exactly 61. We're just kind of trying to see if we can find a correlation or a trend. Okay, so quickly graph those 12 months on there. Did you guys finish graphing? Yeah, just quickly put those 12 points on there. What do you guys think? Is there like a definite relationship between the temperature and electricity bill? Yeah, kind of like right now, right? So what's the trend? What's going on? It's going up. So what does that actually mean? Like when you see this data, what kind of information does it tell you? As the temperature rises, what happens to the bill?
It goes higher.
Why does that happen?
You use more air.
Yeah, you use more AC because it's hotter, right? So then you use more, the AC stays on longer, so then the electricity bill is higher. So there is a definite correlation. So we're going to talk about the different correlations that are kind of available. So these are 5 different correlations that you might see. First, weak positive. Weak positive.
It's kind of contradictory.
Huh? Okay, so positive and negative has to do with the slope, so the direction. And weak and strong has to do with how tight the points are together or apart. So for example, weak positive just means that it's going to be in the positive direction, positive slope, but it's not very tight. So something like that. You can kind of see that it is generally trending in the positive direction, but the points are farther apart. Okay? Strong positive means it's positive direction, but it's going to be tighter together. So it's very, very close. And if I put a straight line through, I can probably predict most of the points. Okay, so please be able to differentiate between weak and strong. Okay, no correlation means that there is just kind of a cloud of points. We can't really tell if there is a relationship between the x and y or not. Weak negative, so we're now going in the negative direction, the negative slope, but it's going to be weak, meaning that it's not very tight together. But generally, it is pointing in the negative direction. And a strong negative means that the points are tighter together and definitely in the negative direction. Okay, so now let's come back to the data. What do you guys think? First of all, so the trend with the temperature and electricity, so is that positive or negative? Positive, definitely, right? So now we have to decide, is this going to be weak or strong?
Strong.
How many people think it's strong? How many people think that looks weak? Oh, yeah. So there's usually, kind of like, wow, it's not easy to differentiate. But for this one, I would say it's strong because it's pretty much all in a straight line. I mean, there's very few things in life that actually is a straight line. We're just saying how tight it is. This one's pretty tight together as a straight line. So now what we're going to do is we're going to create a line of best fit. Line of best fit means the line that best fits all the data points. Meaning if I draw a straight line through, that line should predict most of the points or it's close to predicting most of the points. Okay, then let's do this one then. Okay, so to create a line of best fit, we need to use 2 points, any random 2 points that's on my data. And then I'm going to draw a straight line through and say that that's a pretty good prediction of all my data points. Which 2 points do you guys want to use?
Like the very first top one? Yeah.
The top one? This one?
Yeah, the bottom one.
This one?
Yeah.
Okay, and then so let's say that if we draw a straight line through, it should kind of predict the trend, right? What are 2 bad points to pick? The middle ones?
Like the middle one's like going sideways?
Like the middle.
Middle one's going sideways. Yes, these 2 are bad points, right? If I draw a straight line through, that would be like that. That does not predict my data, correct? So you want to pick 2 points that actually does go through that trend well. Okay, so we are going to use those 2 points. What are those 2 points though? I can't. This one down here is 58, 110. This top one looks like that's the highest temperature. Highest temperature is at 250. Highest bill is 255. So this one's 84, 255. So we're gonna use those 2 points to create a line. How do we do that?
Just do.
Slope. Yep, we gotta find slope first. So 255 minus 110 over 84 minus 58. That is 145 over 28. 26. Oh, sorry, 26. Okay, this one you can use your calculator because the numbers are all going to be pretty crazy. And once you actually find the slope, what are you going to do to find a line? Yeah, pick one of the points. I would probably pick the lower one because the numbers are smaller. And then you're going to create a line. So basically on your homework, that's what you're going to do. That's why I only give you a few problems to do, so you don't have to do a lot of plotting. But everyone's answer is going to be a little different because it depends on which 2 points you pick. But in general, your slope will be close enough. Like if it's a positive trend, it's a positive number, you are not going to get a negative number. If you get a negative number, you pick totally wrong points. Yeah?
So what do we do with the slope count?
You can change it to a decimal so it's easier to calculate.
So after that, we use like have that I see too.
No. You're trying to create a line, so you're going to pick one of the points, which in this case we decided to pick the smaller number point, and then we're going to plug it into like the point slope form or the slope intercept form in order to find the equation of a line.
Okay.
Mm-hmm.
What place do you want us to round to?
Three decimal places.
Okay, so like 1,000?
Yes. All right, let's look at your answer. Your equation should be y equals 577x minus 213.466. So I appreciate those of you who left the slope in fraction form, but in general, when we're writing math, first of all, we don't do mixed numbers anymore because we're in pretty much advanced math, so we don't do mixed numbers anymore. Everything is in improper fraction. That's the first thing. Second thing, if you're going to put decimals, then you don't put decimals and fraction together, bless you, in the same fraction. That's kind of awkward. So choose one. If you're going to do fraction, the whole, bless you, oh man. If you're going to do fraction, the whole thing is fraction. If you're going to do decimal, the whole thing is decimal. So please don't put fraction and decimal in the same equation. That just looks very awkward. Okay, so what I'm saying is a lot of you put the slope as this fraction. Please change it to 5.577. All right, so this is what we do with line of best fit. You pick 2 points, you figure out the slope, and then you draw a straight line through that and calculate the equation. Okay, let's practice. So this table below shows the median home price in Florida. What is the equation of a trend line that models a relationship between time and home price, which means find the line of best fit? Use the equation to predict the median home price in 2020. Okay, so first thing you're going to do is just plot, and we're going to choose the points together. So first plot, and then leave it there for now. We're going to choose which points we want to use. That way everyone gets the same answer. Okay, so really quickly, just plot it. Please don't spend a lot of time. So your points kind of look like that. So what do you guys think? What kind of trend does this have? Strong positive, definitely strong positive. So what does this data tell us? So in the x coordinate is the year. The y coordinate is the home price in Florida. What does that tell us? Yeah, so basically as time goes on, the home prices increase. So if you notice in California, it's the same trend. You know, homes are getting more and more expensive. So you can ask your parents, this is, you know, what's going on these years. Yeah, so home prices are getting expensive. In Florida, it's at $2,000. It's only $100,000. Over here, it's probably like $500,000 already. So yeah, homes are very expensive. So this is a positive correlation, strong positive correlation. Which 2 points do you guys want to pick in order to predict? First and last? Okay, that looks good in this case. So if we draw a straight line through, it looks like that. It does look very good. The wrong ones, again, to pick are these two. That would create a line that does not have points even going in the same direction. And in fact, that looks negative. That's not even positive. So bad points to pick. Okay, so we're going to pick the first and last. That is 1940, 100, and 2000. 105500. So you're going to figure out a line of best fit using those 2 points. Okay, so go ahead and do that. Let me know when you're done. Okay, so the trend line is y equals 1373.333x minus 2641166.667. Okay, so a lot of you looked at it and said, oh, that doesn't look right. That looks too big for my trend line to be correct. So I'm glad you're looking at it and then you're kind of thinking about it instead of just, oh, I got a number, that's it. Now let's talk about why that number is actually correct. Let's look at our origin, or what we decided as the origin. What is the smallest x number here? 1930. What is the smallest, I guess, y here? Well, that one's 20,000, but it looks like it probably went down to 0, right? So the problem is that we did not start at x equals 0. If I actually started at x equals 0, I would go 1,930 to the left, right? So then my graph will go way down. And that's why my y-intercept is very, very, very low. Does that make sense? You guys are not convinced. Okay, so for example, basically what happened was, so let's say that my graph were like this. I am basically looking at my graph at this point in time. And then that is like 1930. And like, what was it, 200,000. So then if I were to draw a straight line down all the way until I actually reach 0, this would be a very, 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 very negative number. And that's why my y-intercept actually does make sense. Does that make sense to you guys?
So it's like the beginning of time.
Right. Because I'm just way too far from the actual.
Houses were first.
Yeah, yes, if it were true, but not everything can be predicted this way.
So the year 2.
Okay, so now what we're going to do is we are not just making these lines for fun. We are actually going to use these lines to predict. So this question says, what would be the actual home price in 2020, which is next year, if we continue this trend? So how would you do that?
Plug in 2020 into the X.
Yes, so X is my year, which is 2020. That's where we want to predict. So we want to figure out the home price, which is going to be Y. So if we plug that into our equation, we should be able to tell what the home price may be next year. Oops. Did you guys get an answer? Jeff got an answer? What's your answer?
I actually used a different number from the beginning.
Oh, is it like really different from this
No,
one?
it's not.
Okay, what number did you get?
It's 135, 660.
Okay, so around that price, you guys all got around that number? 130,000 something? 132. Okay, so if you actually use the same numbers, 132,966. Round to the nearest whole number? Yes.
I have an issue with my calculator.
Oh, okay, I'll come over and check. Okay, so basically we're predicting if it continues in a linear trend, then next year it will cost $132,000 to buy a home in Florida.
Yeah, I was about to say.
That's still nothing, right, compared to California?
I was about to say that's not California.
No, that's not California. At least half $500,000 to start, right, in California.
That's a 1-room apartment in California.
That's probably true. So I'm glad you guys are actually thinking about this because, math is not just, solving something. You have to ask yourself, does it even make sense? So a lot of the word problems, if you think about it, like, why would someone buy 15 watermelon and put it in a car? That kind of stuff, I hope you're thinking like, okay. I mean, I got an answer, but that makes no sense. So please think about it. All right, this one. Let's just have you guys do this one. Everyone's answer is going to be a little different because it depends on which 2 points you pick, but the general idea should be pretty close. So go ahead and do that. Okay, so if you use the 2 endpoints and you created a line of best fit and you're trying to figure out how much milk will cost next year, you got $5.11. That's, kind of the answer you would actually get if you use that line to predict. Now, then you ask yourself, does this make sense?
Yeah.
Next year, how much does milk cost now?
I don't know.
You don't know.
It's like $4.
It's around $4, but it's been $4 for a long time, right? Like,
It'll just go up.
somehow it's hard to keep those cows and.
Well, the gas tax is making everything increase.
That's true. That's true. Yes. So, I guess what I'm trying to say is not everything is linear. If everything is linear, we would be in a world of hurt because there's just a lot of. So, yes. So basically, if world works in a linear direction, then this will be a very expensive milk. But most of the time, world works up and down, and there's some other ways to predict or other equations we can create, so it's not exactly linear. But if we were to do it linearly, this is what we would do.
I think we're predicting recessions. That's like the big thing. That's like the big thing for how it.
Yes, I'm not quite sure if.
I don't think so. I don't think it's gonna happen. But a bunch of people like in news headlines like, "Oh, recession's gonna happen."
Yeah.
Wait, so how do we say how accurate is your line?
Well, I guess what I'm trying to say is that if we continue this trend, in 10 years, our milk will cost like $6, $7, and then you will ask yourself, does this even make sense? Usually, no, milk does not increase to that point. So not everything in life can be predicted by a linear model. But this is just kind of a practice for us to do this. Any questions? This is easy, right? Like, plot and figure out the line and then predict.
So our line is not very accurate.
Our line is accurate, but life cannot always be modeled after linear models. You have a question?
Right, because I have a lot of graphing on the homework.
That's why I give you like what, 6 problems, 5-6 problems.
But it's all graphing.
Graphing, create a line, predict.
Can we use graph paper?
Yes, please use graph paper. I have a lot of graph paper over there. Other questions? You okay? All right.